In today's fast paced world, stress management is often overlooked, with wellness apps missing the mark on personalized emotional support. Embrace AI addresses this by harnessing TidyB's vast serverless infrastructure and vector search for efficient on and off policy learning, solving issues like slow data queries and complex AI adoption. Embrace AI also serves as a learning tool, helping engineers understand and apply these advanced AI techniques. Our solution uses AI Swarm to capture users' emotional expressions from facial images and location data processed through a custom convolution neural network, and text embedding AI from huggingface.com to generate vector embeddings. These vectors are sent to our API and stored in TidyB's serverless database. Our reinforcement learning model then leverages on policy and off policy algorithms, vector search, and a recommendations table to choose the best mindfulness exercise based on the user's emotion and location. Q Learning adjusts the model with user feedback, refining future suggestions while leaving Q values unchanged if no feedback is given. The feedback loop parallels the stoic metaphor of a dog tied to a moving wagon. The wagon will continue going down the path. The dog can choose to willingly walk with the wagon or struggle and be dragged by it. The destination remains the same. The wagon represents the guided path of our exercise suggestions powered by TidyP, and the dog, our reinforcement learning agent, earns its rest by selecting exercises that align with user feedback, enhancing the system's effectiveness over time. Now let's see how it works. Our goal is to classify an emotion and understand the location it's taking place to see correlations. We also don't want our solution to suggest a yoga pose while the user is in a commercial location like the grocery store. So I'll pick an emotion card to classify the emotion. The picture is sent to the CNN AI that stores model processing information in TidyB that reads the emotion from the picture, then categorizes it as one of three categories: happy, angry, or sad. That emotion classification and user location is sent to an additional AI that turns words into numbers. Then our AI, based on the dog wagon metaphor, picks the best mindfulness exercise based on those vectorized numbers. The recommendation table populates the off policy exercises with Q values, while the on policy approach uses TidyB's cosine similarity function to calculate the cosine distance between vectors, which serves as our Q value. If this Q value exceeds a set threshold, the corresponding exercise is suggested as the best option. Using the feedback text information that's stored in TidyB's database, user feedback is given and Q values are updated. When it comes to Q values, usually the higher the score, the better the grouped categories, and the leaderboard shows this. Before I update the leaderboard with user feedback, and once we receive the positive or negative user feedback, the Q values will be updated. I can also see feedback scores from past suggested mindfulness exercises based on the selected emotion. The goal is to see an upward trend in scores, indicating improved effectiveness with Q values from the dog wagon AI in selecting exercises. We can see our agent, our dog, is learning its environment effectively and picking the best path to get the most useful mindfulness exercise, also showing the effectiveness of vector semantic search policy from TidyP. We can also see how efficiently our dog wagon AI leverages TidyB to select the correct mindfulness exercise. It displays the number of records with retrieval times and database alongside computer resource usage. Then lastly, I have my learning tab to provide a brief overview of our AI models and TidyB's vector semantic search. There's also a link to download the AI Swarm workflow PDF used in this project and the GitHub projects.